Tonight, we're floating across the surface of Earth's most mysterious realm, the ocean. We'll explore the hidden mountains that lie beneath its waves, the glowing creatures that light up its darkness, and the deep trenches that sink farther than Everest stands tall. You'll hear how the sea breathes for our planet, how its rhythms shape every storm, and why we've still only glimpsed a fraction of its wonders. Now take a deep breath. Let your thoughts slow. Let the tides in your mind match the rhythm of the waves. And together, let's begin our descent into the endless blue. Look at a photo of Earth from space. And the first thing that hits you isn't forests or cities. It's blue. Not a pale hint of blue, but a deep, living color that swallows continents and stitches them together with a single, endless sweep. More than 70% of our planet is ocean. Imagine that. An unbroken expanse of water stretching for thousands of miles, and the Pacific alone is bigger than all the continents combined. It's hard to wrap your head around until you stand at a shoreline and feel that size in your chest. That vastness isn't just scenery. The oceans are the engine room of Earth's weather and life. When the sun warms seawater, evaporation lifts tiny molecules into the sky that later become the clouds that shade you on a hot day, or the rain that wakes you with a soft patter on the roof. The water cycle that shapes our days. Drizzle on your commute, sudden summer storms, the snow that delays flights. All of it starts out in those blue stretches. Every thunderstorm, every foggy morning by the coast is a small footnote of that enormous, humming system. And the ocean doesn't just move water. It makes air. Microscopic organisms called phytoplankton live suspended near the surface and perform photosynthesis on a planetary scale. They're tiny, but together, they produce a significant chunk of the oxygen we breathe. Think about that. Next time you take a deep breath at the beach. Some of that oxygen began as life in the ocean. The idea that our lungs are partly fed by something so far away and so different is humbling, and frankly, kind of miraculous. We also carry the ocean inside our rhythms. Tides driven by the moon pull at our coastlines in predictable ways, and even inland communities feel their influence through weather patterns and seaborne storms. For many of us, memories link directly to the sea. The smell of salt in the air from a childhood vacation, the feeling of sand underfoot, the calm of watching waves roll in. Those personal moments are connected to a planetary heartbeat, a literal pulse of currents, thermals, and life that keeps Earth stable enough for us to flourish. Yet there's mystery too. We've mapped the surfaces of other worlds with more detail than the deep ocean floor. Most of the oceans remain unvisited by humans, and inside them are species, ecosystems, and currents we're still learning to understand. That uncertainty should inspire wonder, yes, but also a sense of care. The blue that defines our planet is fragile and full of interdependencies. It gives us clouds, rain, and the very air we breathe. It's the living pulse that makes Earth unique. Think about the last time you stood at the edge of the sea, watching waves fold over themselves, hearing gulls, feeling the sand give under your feet. It's easy to assume the ocean floor is flat and silent, a distant monochrome plain. But beneath that surface lies a landscape wilder than any we walk on every day. Entire mountain ranges, yawning canyons, and volcanoes, all hidden in the dark. Imagine hiking a mountain ridge, but instead of air and trees, you're surrounded by cold, crushing water, and the only light comes from your headlamp. The mid-ocean ridges are exactly that. Mountains born from fire. The global mid-ocean ridge system stretches more than 40,000 miles, and at its seams, molten rock rises from deep inside the earth, cools, and becomes new seafloor. It's not a one-time event. It's happening continuously. Every hour, in places no human eyes normally see, Earth is being made. These ridges don't look like a single neat line on a map. They are a messy spine of peaks and valleys, fissures and lava flows. Some of the peaks thrust thousands of feet above the surrounding sea floor. Between them are trenches that could swallow the tallest skyscrapers. There are underwater volcanoes that erupt with a quiet, alien fury, and canyons carved by currents so powerful they move tons of sediment. If you like exploring national parks or climbing a favorite hill, picture all of that, but scaled up and sculpted by water and fire instead of wind and rain. What's stunning is how alive these hidden places are. Where molten rock meets seawater, hydrothermal vents form, towering chimneys spewing mineral-rich hot water. At first glance, they look hostile, pitch black, superheated plumes billowing into the abyss. Yet around those vents, a strange oasis of life thrives. Giant tube worms, blind crabs, and clouds of shrimp survive not on sunlight but on chemistry. Microbes use energy from the earth itself, turning chemicals into food in a process called chemosynthesis. It's a reminder that life finds a way in even the most unexpected corners. And there's a hum of motion you can't see from shore. As new crust forms at the ridges, tectonic plates slowly pull apart and drift. That motion reshapes the ocean basins and, over millions of years, redraws continents. The seafloor we walk on mentally when we imagine the deep is not permanent. It's being born, stretched, and recycled. In human terms, the changes are slow, almost glacial. In geological terms, they are a ceaseless, dynamic dance. I like to think about how small our daily perspectives are compared to this secret, ongoing geology. The next time you stand on a coast or look at a map of the world, remember that underneath the water there's a mountain range as long as the planet. Picture molten rock popping up, cooling into rock, then new life colonizing those fresh surfaces. It gives a peculiar comfort. Even in places we can't easily visit, the planet is constantly renewing itself. If you have ever stood at a lookout and watched clouds race over ridges, or felt the hush at the top of a peak, try to bring that feeling down with you, beneath the waves. The hidden mountains there are no less dramatic. They are just quieter about their drama, reshaping the world far from our everyday sight, but shaping the home we all share. Close your eyes for a second and picture the tallest thing you've ever seen, maybe a skyscraper or a mountain in a photo. Now imagine that mountain sinking beneath so much water you can't even see its peak. That's what the Challenger Deep in the Mariana Trench does to Mount Everest. Nearly 7 miles straight down, the trench swallows up anything we think of as big on land. If Everest were dropped into that hole, it would vanish under more than a mile of seawater. That scale is almost impossible to grasp until you try to put yourself there. Think about the air around you right now. One atmosphere of pressure. At the bottom of Challenger Deep, the pressure is roughly 1,000 times greater. If you were a human without a vessel, that force would compress your body like a soda can. Even engineered metal resists. Any human-made thing down there must be built to withstand an aggression of nature that feels personal, like standing against a tidal wall that never stops pushing. And yet, stubbornly and beautifully, Life refuses to accept being shut out. There are whole worlds operating in that darkness. When the sunlight ends, and it ends very quickly, within a few hundred meters, every creature that survives does it differently. Some are armored with shells built for crushing pressure. Others are soft-bodied, their tissues adapted to the cold and the squeeze. There are tiny scavengers that feast on the slow rain of organic matter falling from the surface, and there are bizarre gelatinous fish that look almost translucent, as if someone sketched a creature and then forgot to color it in. If you could sit inside a tiny observation port at the very bottom, it would be almost unbearably silent. No waves, no wind, just a deep, tactile quiet. And then, in that quiet, you might notice movement. A pale, ghostly amphipod scuttling over the mud, or a solitary snailfish hovering inches above the sediment, its body adapted to the crushing environment. Some of these animals glow. Bioluminescence is the language of the dark ocean. Flashes, slow pulses, flickers that say, "I'm here," or "I'm warning you," or "I'm looking for a mate." Watching that light is like watching a city at night. Only the skyline belongs to creatures smaller than your hand. Human exploration of Challenger Deep is a story threaded with audacity. In 1960, the bathyscaphe Trieste carried Jacques Piccard and Don Walsh down into that blackness, the first people to see it firsthand. They reported an otherworldly seabed, a plain of ooze and strange rocks. Decades later, in 2012, filmmaker James Cameron journeyed down alone in a custom submersible. More recently, scientific teams have sent remotely operated vehicles and instruments to map and sample the trench. Each descent is a reminder. We've reached the lowest place on Earth, and it still surprises us. Part of what makes the Challenger Deep feel so intimate is how it connects to us. The detritus that feeds life down there often begins as something we discard at the surface. The bodies of tiny plankton, fragments of marine snow, or even pollutants. That slow rain links our kitchen tables and factory outputs to creatures that have never known sunlight. In a very real way, what happens in our daily lives, what we eat, throw away, or pump into the air, eventually finds its way to those abyssal neighbors. It's a humbling thought. Even the remotest place on the planet is touched by human activity. There's also a quiet bravery to the animals of Challenger Deep. They don't have cities or shelters, but their adaptations are solutions written in their bodies. Flexible bones, specialized enzymes that function under pressure, slow metabolisms tuned to scarcity. These are biological answers to problems most of us never have to face. When you think about persistence as a personal trait, you can see it mirrored here. They persist not by willpower, but by evolution, a patient, relentless tinkering that has produced life where we assumed none could exist. So the next time you glance at a mountain photo or scroll past an ocean clip, remember the view you can't see, a place where a mile-high mountain would drown without a sound, where pressure would make a normal body impossible, and yet where glowing life moves on. The Challenger Deep is a reminder that Earth's extremes are not empty. They're full of stories, survival, and a subtle, stubborn beauty that keeps whispering even in the very deepest dark. Picture the last time you stood at the edge of a shoreline, waves folding over your feet, that salt smell in the air, the horizon that refuses to end. It's easy to feel small there, but what you're really seeing is the heart of Earth's water. Nearly 95% of all the water on this planet sits in the ocean. That vast, restless body of water is not just a backdrop. It's the main reservoir, the system's engine, the place almost everything else feeds from and returns to. Rivers, lakes, even the massive sheets of ice we call glaciers. They're visible, familiar, comforting. They're where we swim, where we drink, where we take that postcard photo. But in the grand accounting of Earth's water, they're a sliver. Imagine a pie chart where one enormous slice is the ocean and the rest is a handful of crumbs. That's the scale we're talking about. Those rivers and lakes and glaciers matter deeply to local lives and ecosystems, but in terms of sheer volume, the ocean holds the lion's share. That fact changes how you might think about every single drop you touch. Think about the glass of water you had this morning, the rain that tapped on your window last week, the sweat on your brow after a run. Every single one of those molecules has been everywhere before. Every drop of water you've ever touched has once been part of the sea. It's a humbling, almost poetic truth. Your daily water has been carried by currents, warmed by sunlight, maybe evaporated into air above a distant ocean, condensed into a cloud, carried on winds, and poured down over the place you call home. That journey, evaporation, cloud formation, rain, runoff, and rivers returning to the ocean, is what keeps our planet alive. It's not a static loop. It's a dynamic planetary system. When the sun warms the ocean's surface, tiny molecules of water escape into the air. They rise, cool, clump together as droplets, and become clouds. Those clouds travel, sometimes hundreds or thousands of miles, riding winds and weather patterns. Eventually, they release their burden as rain, sleet, or snow. Water lands on mountains, soaks into soils, and begins a journey back down. Some of it feeds ecosystems, some replenishes groundwater, some forms streams that join into rivers, and many of those rivers lead, eventually, inevitably, back to the ocean. If you've stood in a thunderstorm and let the rain soak your face, you were part of that ancient cycle. If you poured lake water on a potted plant, its roots drank from a system that last touched the sea maybe centuries ago. If you filled a bottle from the tap, that water's molecules probably spent time in the ocean a very long time before being cycled into treatment plants and pipes. That continuity makes water unique among Earth's resources. It's constantly recycled, shared across time and space, and forever linked in ways we rarely notice. The ocean's role in this cycle goes beyond being a reservoir. It moderates climate, stores heat, and powers weather systems. Currents like the Gulf Stream carry warmth from the equator to higher latitudes. Upwelling zones bring nutrient-rich waters to the surface, supporting massive networks of life, from plankton to whales. The ocean's surface exchanges vast quantities of moisture with the atmosphere, a continuous give and take that shapes the weather where you live. When people talk about global weather, they're really talking about an intimate conversation between sea and sky. For humans, the ocean is personal in smaller, quieter ways too. Think of childhood memories, a summer at the coast, pockets of sand in your shoes, seaweed that smelled like summer and mystery. Think of the sound of rain on a tin roof that made you fall asleep, not knowing those droplets once rode oceanic winds. Even the water in your body carries that memory. Most adult humans are roughly 60% water, and those molecules have been on an epic tour over geological time. You are, literally, partly ocean. That perspective changes how we think about stewardship. If the ocean is the wellspring that feeds rivers, clouds, glaciers, and eventually our taps, then when the ocean changes, everything downstream feels it. Warming seas alter evaporation patterns. Changes in salinity and current strength shift climate zones. Pollutants that enter the sea don't stay confined. They are woven into the cycle and can reappear in unexpected places as rain or in the tissues of fish we eat. The ocean is vast, yes, but its reach is intimate and immediate. And there's beauty in that intimacy. Consider the idea that the molecules in a single cup of seawater have histories spanning continents and centuries. Some might have been part of a tropical storm that drenched an island 100 years ago. Others might have been frozen in an Arctic glacier, trapped for millennia before melting and returning to circulation. When you hold water, a cup, a rain-soaked sleeve, a dripping towel, you're holding a liquid archive of Earth's climate and movement. So the next time you take a sip, or stand under a summer shower, or watch a river spool away into the distance, remember where that water's story likely begins and ends: the ocean. Not as a distant thing, but as the central, beating heart of a system that makes weather, feeds ecosystems, and links every single one of us. That recognition doesn't only inspire awe, it invites responsibility. The endless cycle that keeps the planet alive is also fragile, and our everyday choices echo through it. Now picture the ocean floor not as a silent, flat plain, but as a world of fire and creation. Most volcanic activity on Earth happens underwater. Along the planet's mid-ocean ridges, endless seams where tectonic plates slowly pull apart, molten rock wells up and forms new crust. These ridges are huge, longer than the mountain chains on land, and their slow, steady birth of rock fuels something truly alien to anyone who's only seen volcanoes from shore: hydrothermal vents. Hydrothermal vents are like underwater forges. Seawater sinks into fractured basalt, gets heated by underlying magma, and then spews back out through cracks in the sea floor. That superheated fluid can be hotter than 400 degrees C, but because of the crushing pressure kilometers under the sea, it doesn't boil. When that hot, mineral-rich water meets near-freezing seawater, metals and sulfides precipitate out and build towering chimneys. The dramatic, black smokers. They look like chimneys on video, belching dark, smoking plumes. But what they're really doing is assembling new rock and scattering a stew of chemicals into the ocean. Here's the part that changes how I look at life on this planet. Those harsh, lightless vent fields support entire ecosystems, and they aren't powered by sunlight. Instead of photosynthesis, life here runs on chemistry. Microbes living in the vent fluid oxidize hydrogen sulfide, methane, and other reduced compounds, harvesting energy from chemical reactions. They're effectively tiny factories converting inorganic chemicals into biomass. That chemosynthesis feeds bacteria mats and microbial symbionts, which then nourish a community of tube worms, like the iconic Riftia with its feathery red plumes, giant clams, shrimp, crabs, and fishes adapted to the heat and metal soup. If you've ever stood near a hot spring and watched it steam, you have a tiny, familiar mental image to hang on to. Imagine that on a massive, cold, black stage, and instead of steam, it's a glowing plume of metal-rich water supporting entire communities. I love to imagine how the first scientists felt in 1977, looking down through the submersible Alvin and seeing for the first time these oases of life in complete darkness. It must have felt like stumbling onto a neon-lit city in a canyon where you expected only stone. There are different flavors of vents. Black smokers spew sulfide-rich, dark plumes and build towering chimneys. White smokers emit cooler, silica and barium-rich fluids that form paler structures. Vents can be transient. Some spring up and die over years or decades, and that temporal nature makes their communities dynamic, with species adapted to colonize quickly or ride out change. Vents do more than host strange life. They play a role in global processes. Hydrothermal circulation alters ocean chemistry, helps cycle minerals, and even locks some carbon into oceanic crust. The mineral deposits formed around vents concentrate metals like copper, zinc, and sometimes precious metals. That's why deep-sea mining has risen as a contentious topic. These fields could be sources of valuable ore, but they're also fragile ecosystems we barely understand. There's also a cosmic angle that turns my curiosity into wonder. If life can thrive in total darkness using chemical energy here, then similar systems could exist on icy moons with subsurface oceans, Europa or Enceladus, for example. Hydrothermal vents expand the definition of where life might be possible. They suggest that anywhere with liquid water, heat, and chemical gradients, life could find a foothold. So when you think volcano, don't only picture ash clouds and flowing lava on land. Deep below, volcanoes quietly build new crust and light up the abyss with chemistry, not sunlight. They create rugged, ephemeral worlds that test the limits of life and broaden our ideas about how and where living systems can exist. And that, to me, is one of the most humbling and exciting parts of exploring our planet. Imagine stepping into a place where every corner hums with life. Not a city of buildings and cars, but a city made of color, texture, and movement. That's the Great Barrier Reef. Stretching along Australia's northeastern coast, it's the largest living structure on Earth. So vast people can actually see it from space. I still remember the first time I saw footage of it, that mosaic of blues and greens, and suddenly the scale hit me. It wasn't just pretty, it was a whole world. What's incredible is that this city is built by creatures you could barely see with the naked eye. Coral polyps, each smaller than a grain of rice, quietly secrete limestone and multiply over generations to make reefs that can last thousands of years. Picture billions of these tiny animals, all doing the same small thing over and over, and together they create neighborhoods, towers, alleyways, and plazas for marine life. It's a reminder that immense systems can arise from the tiniest, most ordinary actions. A humbling thought when you consider our own communities. When you swim along a reef, it feels like walking down a bustling street market. Schools of fish weave through coral branches like pedestrians slipping through stalls. Sea turtles drift slowly like wise elders making their rounds. Anemones and clownfish form little storefronts, while moray eels peek from crevices like watchful shopkeepers. Scientists estimate that about a quarter of all ocean species depend on coral reefs at some point in their lives, even though reefs cover less than 1% of the seafloor. That compressed importance, so much life packed into such a small area, is one reason reefs are often called the rainforests of the sea. For many people, the reef is personal. Maybe your first snorkel trip was here, the moment you realized how differently life moves underwater. I remember bobbing on the surface, mask fogged, heart a little fast, then leaning down and seeing a flash of orange and white, a clownfish darting through an anemone, and feeling a simple, bright joy. It's easy to take that feeling for granted until you learn what keeps that joy alive. The delicate balance between coral animals, algae, fish, water temperature, and clean seas. When one part of the system is stressed, the whole neighborhood feels it. That's also why the reef's health matters to people who aren't divers or marine biologists. It supports fishing communities and tourism. It buffers coastlines from storm surges and erosion. It stores cultural memory and provides inspiration. Indigenous Australian communities have connections to these waters that go back tens of thousands of years, with stories and knowledge woven into the reef itself. For local families, the reef is a source of food, livelihood, and identity, not just a distant natural wonder. At the same time, the picture isn't just idyllic. Rising sea temperatures, pollution, and other pressures have caused bleaching events and habitat loss in parts of the reef. That's heartbreaking when you've felt the reef's pulse firsthand. But it's also a call to action that feels achievable when you remember the reef's building blocks are so small. Small actions add up. Better choices on plastic use, supporting responsible tourism, reducing carbon footprints, and backing restoration projects. Scientists are even exploring techniques like coral gardening and selective breeding for heat-tolerant corals. Reminders that human ingenuity can help if we move with care and urgency. So when you think of the Great Barrier Reef, think of two things together: massive scale and intimate detail. It's a structure you can follow from space, and a handful of creatures you can watch through a mask. It's a living city with neighbors who matter. And like any city we love, our hometowns, the parks where we walked as kids, it depends on our attention to keep thriving. If you've been lucky enough to visit, that memory can fuel a desire to protect it. If you haven't, let that image of tiny polyps building monumental neighborhoods be a reason to care. The reef's future will be shaped by billions of small acts, by the same principle that made it in the first place. Some nights the ocean doesn't just reflect the stars, it borrows them. Imagine standing on the sand after midnight, the world hushed except for a soft rush of waves. You reach down, scoop a handful of seawater, and it explodes into tiny electric blue sparks that cling to your skin like confetti from some impossible celebration. That's not a trick of your eyes or a camera effect. It's bioluminescence, the sea's own living light. Most of the time when we think of light, we picture the sun or a lamp, something external to us. But in the ocean, light is often born from the creatures themselves. At the surface, it's usually microscopic. Plankton and single-celled organisms called dinoflagellates. When a wave breaks or your hand disturbs the water, these tiny organisms respond by producing light. The result is those shimmering, ghostly trails that follow a passing kayak or a swimmer's fingertips. People call it phosphorescence when it lingers and bioluminescence more generally, but either way, the effect is impossible to describe fully without seeing it. You have to feel that cold, saline splash on your wrist and watch the water bloom like a constellation in miniature. I remember a night paddling in a small bay, nervous and utterly awake. Every stroke left a comet tail behind the paddle. I'd dip my fingers and watch sparks run along my skin. It felt like touching a galaxy. It wasn't grandeur in an abstract sense. It was intimate. You could almost believe the ocean had put a tiny star in your palm, just so you'd know you weren't alone in the dark. Deeper down, bioluminescence takes on more strategic roles. It's not just pretty, it's survival. Many jellyfish, squid, and fish have evolved light-producing organs called photophores. Some use them to attract prey, a lure that pulses in patterns tuned to the tastes and instincts of smaller animals. Picture a squid hanging in the blackness, a soft glow like a lure at the tip of an inviting appendage. An unaware fish approaches, thinking it's something edible, and the squid strikes. Other species use light to communicate. Flashes and patterns can say, "Stay away," "Come here," or even, "I'm injured." A complex language of flashes and pauses. One of the smartest tricks is counter-illumination. In certain midwater fish, the belly glows to match the faint light coming from above. From below, a predator looking up sees only the distant, diffuse daylight and misses the fish against the glow. Camouflage by illumination. It's like wearing a cloak of sky. When you picture the deep sea as only a place of crushing pressure and eternal blackness, remember this: life has turned darkness into a canvas, painting messages and traps in photons. The chemistry behind it is elegantly simple. Many organisms produce light through a reaction between a molecule called luciferin and an enzyme called luciferase. When they react, energy releases as visible light. It's efficient, no heat, just cold, cold light, which is perfect when you can't afford to waste energy in the deep. In some cases, animals don't make the chemicals themselves, but host glowing bacteria instead, like a living light bulb powered by tiny symbiotic partners. It's cooperation at the molecular level. There's something deeply human about seeing those lights. When we look at a glowing shore or a drifting colony of jellyfish, we often feel a hush that's equal parts wonder and humility. Stories and myths sprang up around these lights long before science explained them. Coastal communities have legends about lantern-like spirits guiding fishermen, warnings about restless tides, or romantic tales of lovers turning into starry sea foam. Even now, when you see a video of a glowing wave on social media, people stop scrolling and leave comments like, "I need to see this," or "My heart." It connects to something primal, our love of light in darkness. Still, these displays are fragile. They depend on water quality, temperature, and the right ecosystems, so human activity matters. Pollution, coastal development, and irresponsible tourism can dim these bioluminescent shows. If you ever get the chance to see the phenomenon in person, there are a few simple rules. Keep noise and disturbance to a minimum. Don't use bright lights or flash photography, and never collect animals just to get a closer look. Seeing the living light is a privilege, and the best souvenirs are the memories and the photos people rarely find that capture that electric blue in full. There's also an ethical wonder to it, knowing that the glow is something the creatures use daily. It's not a display for us, it's their language and survival tool. That thought makes the experience feel less like a spectacle and more like eavesdropping on a conversation you weren't meant to hear. It's beautiful and intimate in a way that asks for quiet respect. Back on shore, after a cold splash and a bunch of giggles, you keep looking at your hands. The glow fades, but something about the memory lingers, a small, stubborn reminder that even in the deepest dark, life finds a way to shine. The ocean's bioluminescence is a literal illumination of that idea, beauty and ingenuity arising where we least expect it. And as we begin to explore how humans have learned from and harnessed this light, from scientific research to art and design, you start to see that these tiny living stars have already brightened more than just the night. They've lit up our curiosity. Night after night, something extraordinary happens far beyond our sight. Billions upon billions of tiny lives lift themselves out of the deep and drift toward the surface. It's not a stampede or a stamp of hooves, but a slow, purposeful rise, a migration measured in inches and meters, in moonlight and slow currents. If you could be there to watch, the ocean would look like a city at dusk, lights blinking on, people heading to the same few places for food and company. Start small. Microscopic plankton, the drifters of the sea, begin the exodus first. These are the creatures most of us never see: copepods, krill, and other zooplankton. And they do something remarkable. When night falls, they float up to the sunlit surface to feed on phytoplankton or graze on surface productivity. For them, the surface is a buffet. For the rest, it's a signal. Fish and squid time their moves to follow this surge of prey. Lanternfish, myctophids, and 1,000 other species rise from twilight depths, mouths ready, fins cutting through the cooling water. Predators follow the procession: bigger fish, squid-eating dolphins, and sneaking sharks that know where the banquet will be. This isn't random. It's a rhythm, a pattern as regular as brushing your teeth before bed. The deeper you go, the stranger the logic becomes. Many of these animals spend the day in the darkness to avoid eyes that hunt by sight, then risk the surface when the sun goes down and the predator's vision dulls. For the small plankton, the surface is worth the risk because of food and warmer water. For their predators, the surface is where the grocery store is open. Think of it like the city's late-night food truck scene. Everyone knows where the good bites are, and everyone times their arrival so the lines overlap. There's something intimate about imagining yourself among them. Picture standing on the deck of a small boat under a moonless sky. You can't see the migration with your bare eyes, but if you shine a light into the water, you might pick up streaks of bioluminescence, tiny glows that mark movement like fireflies through the dark. Those twinkles trace the paths of creatures crossing layers of cold and warm water, seeking food and refuge. You feel the water's hush, and in that quiet, you realize that the ocean is breathing in a pattern you never learned in school. A vast nocturnal inhale towards the surface, a slow exhale back into the deep at dawn. This nightly movement is immense. Scientists call it the largest animal migration on Earth by biomass. It's not the dramatic, above-ground migrations that make headlines, but its scale is staggering. A vertical migration involving trillions of organisms every single night. And it matters for more than feeding chains. Each evening's ascent carries carbon from surface waters down again when they sink back. A hidden way the ocean helps lock away CO2, a planetary service we all rely on. The ocean's heartbeat, in other words, isn't just poetic. It's a working mechanical rhythm that helps regulate our climate. There's also a human side to it. Most of us don't experience this migration directly, but its echoes reach us. Fishermen who work at night know where to set their nets by following the glow of lanternfish on sonar screens. Night divers sometimes surface with stories of bioluminescent clouds clinging to their suits. And for communities that depend on the sea, shifts in these patterns, due to warming, overfishing, or light pollution, mean shifts in livelihoods. When the migration changes, the whole chain unravels a little. Fewer prey where and when predators expect them, altered breeding cues, and ripple effects that circle back to people. At dawn, the surface empties. As light climbs, the small creatures tuck themselves back into the deep where shadows and cold offer safety. Fish and squid disappear into canyons and twilight zones, leaving the surface calm and deceptively empty to our eyes. But below, the ocean remembers. Each night repeats the same dance, an ancient habit written into millions of genomes and tuned by evolution. So the next time you think of the sea as a lonely blue expanse, try thinking of it like a sleeping city with its own rush hour, invisible to us, vital to the planet. The nightly migration is quietly heroic, billions of tiny lives making a collective choice every evening, moving between risk and reward, keeping ecosystems running. It's the ocean's quiet heartbeat, and even if we don't watch it with our own eyes, we are riding its pulse every day. Think about a calm lake at dawn, the kind you've stood beside, coffee in hand, watching mist lift off the surface. Now imagine that lake is a pale, glassy patch sitting on the seafloor, and above it stretches thousands of meters of dark ocean. That uncanny contrast is exactly what scientists find when submersibles descend on brine pools, shimmering basins of super salty water that behave like lakes, right beneath the waves. The first time I saw footage of one, it stopped me. For a moment I forgot I was looking through a screen and not at some alien landscape. The pool's surface looked mirror smooth, reflecting the glow of the submersible's lights. Around its edges, sediment formed neat beaches. Little ripples moved across the brine as if wind had found a way down there. It's beautiful in a way that's almost wrong. Beautiful because it's serene, and wrong because everything about it is hostile to life as we usually know it. These brine lakes form when incredibly dense, salty water settles into depressions on the seafloor. Because the brine is heavier than surrounding seawater, it stays put, creating a distinct layer separated by a sharp boundary called a halocline. Cross that invisible line, and the instruments on a submersible suddenly read a different world. Salinity spikes, oxygen plummets, and visibility changes. Pilots say it can feel like driving through fog, except the fog is a wall you can't breathe through. That halocline is where a lot of the drama happens. Light bends, particles dance, and tiny eddies trace the meeting of two fluids that refuse to mix. From the sub's window, it looks almost theatrical, a curtain tearing aside to reveal a secret stage. Cameras capture the surface shimmering. Then, at the edge, a slow spill where brine cascades down a slope like a dense, invisible waterfall. It's the ocean's own plumbing system, rivers of saline rolling across the bottom, carving and reshaping landscapes at scales you'd never notice from the surface. But this beauty carries danger. The brine is anoxic, lacking oxygen, and often rich in hydrogen sulfide and other chemicals toxic to familiar life. If a submersible's thrusters push it into the basin, sensors and engines can be challenged by sudden conductivity changes and corrosive conditions. For animals, too, the basin is a minefield. Most surface species can't tolerate those extremes. Yet, paradoxically, brine pools are islands of life in their own right. Around their perimeters and at the chemical interfaces, chemosynthetic communities flourish. Bacteria that eat chemicals instead of sunlight form the base of food webs, and specialized worms, clams, and shrimp take advantage of abundant nutrients. That's part of what makes these places feel otherworldly. On one side, nothing as we understand it. On the other, life adapted to a chemistry textbook we barely learned in high school. Watching footage of tube worms waving at the brine's margins, it's impossible not to admire evolution's stubborn creativity. It also makes you reflect. We think of oceans as continuous, but hidden within them are contained, self-ruled environments with their own physics and life. For anyone who loves exploration, brine pools are an invitation and a warning. They remind us that the sea isn't homogeneous. It holds hidden rooms with different air, different rules. And for people watching at home, maybe the next time you're by a lake or staring at a glass of salt water, you'll remember that somewhere below, the ocean hides mirrors and rivers, quiet and radiant, both fragile and ferociously foreign. Now consider the ocean's quiet work. Tiny, drifting organisms so small you could fit millions on the head of a pin. They're called phytoplankton, and they live in the sunlit layer near the surface. You don't see them when you walk along the shore, and you can't spot them from a distance, but they're everywhere. An invisible green haze that fills the water with life. Imagine a city of microscopic factories, each one harnessing sunlight to make oxygen. Together, they're responsible for more than half of the oxygen in the air you breathe. Put simply, every second breath you take likely came from the ocean. That fact has a way of changing how you think about a single inhale. Most of us picture trees and forests as the planet's lungs, and they are vital. But the ocean has its own set of lungs that work at a scale we rarely notice. Phytoplankton perform photosynthesis just like land plants. They take in carbon dioxide, use sunlight to create energy, and release oxygen as a byproduct. They are tiny, yes, but countless. Their combined output shapes the composition of the atmosphere and stabilizes climates and ecosystems. When you slow down and feel your chest rise, there's a whole underwater world to thank for that breath. This is where it gets personal. Think about a time you were near the sea, the smell of salt, the distant crash of waves, the sunlight spreading across the water. You were experiencing the surface of a system that's doing something profound out of sight. If you've ever stood on a cliff or a pier and simply breathed deeply, you were participating in a conversation between you and the ocean. Every inhale carried the signature of those microscopic organisms, and every exhale traced a tiny loop back to the water. It's intimate in a way that's easy to forget. Your body relies on processes that happen in places you'll never touch directly. Phytoplankton aren't just oxygen factories. They're the base of the marine food web. Tiny animals called zooplankton graze on them. Small fish eat the zooplankton. Larger predators eat the fish. The life cycle of whales, tuna, and even seabirds depends on the productivity of these minute plants. When phytoplankton flourish, ecosystems thrive. When they decline, the ripple effects are dramatic. That chain reaction links your breakfast, whether it's fish, a salad with seaweed, or simply the air you breathe, to a microscopic population in distant seas. Because they are driven by light and nutrients, phytoplankton populations can change quickly. Warm water, changes in currents, and nutrient runoff from land can all influence blooms and busts. Some blooms are vibrant, even visible from satellites as swathes of green or turquoise, while others are subtle shifts you'd never notice. Scientists monitor these shifts because they're early indicators of broader environmental changes, clues about ocean health, climate shifts, and even the balance of oxygen production. In other words, the tiny flickers of photosynthesis happening every day are also a kind of planetary pulse, and researchers listen closely. You might ask, can we help protect these invisible lungs? The answer is yes, and it starts with choices that matter beyond the shoreline. Reducing runoff of fertilizers and pollutants from farms and cities helps keep nutrient levels balanced so that phytoplankton communities stay healthy rather than becoming imbalanced with harmful blooms. Cutting carbon emissions addresses ocean warming and acidification, both of which affect phytoplankton physiology and distribution. Support for marine protected areas and responsible fisheries helps preserve the food webs that phytoplankton support. These aren't abstract policies. They're actions that sustain a system that literally breathes for us. On a simpler, more immediate level, this connection invites a change in perspective. When you walk by the ocean, or even open a window and feel the breeze, think of the exchange taking place. Take a breath with intention. It can be a small ritual, a reminder that your body is part of a global network of life. Tell someone about it. Share a photo of the sea and caption it with the fact that one of their breaths came from the ocean. The knowledge transforms casual moments into reminders of interdependence. Visually, this section can be subtle but powerful. Close-ups of microscopic life under a microscope, time-lapse of sunlight penetrating waves, satellite imagery showing swaths of phytoplankton, and quiet human moments. Someone breathing in by the water's edge, a child blowing on a dandelion, will link the unseen biological chorus to everyday life. Let the soundtrack be light and rhythmic, mirroring the steady, almost medicinal cadence of breath. Phytoplankton are small, unseen, and innumerable, but their impact is enormous. They are the planet's unsung lungs, each tiny cell flickering green with sunlight and releasing the air we need to live. Every second breath you take is a gift from the ocean, a reminder that our survival is stitched to ecosystems far beyond our sight. Remember that next time you inhale, you're sharing air with the sea. You've stood at the water's edge and felt how small you are next to the sea. Imagine now looking beneath that surface and discovering a hidden river, a river so wide it wraps the planet. Beneath the surface, powerful currents carry warm water toward the poles and return cold water back again, a global conveyor belt of heat and life. That sentence can sound like science class, but it's really about something much more human. The slow, patient movement that keeps the world familiar and livable. Picture making a cup of tea. You pour hot water into a cold cup and swirl it. The warmth spreads, mixing until everything settles at the same temperature. The ocean does the same thing, only on a scale that would make your kitchen feel microscopic. Warm water from the tropics travels poleward near the surface, giving away heat to the air above. That warmth moderates climates. Think of how Western Europe is milder than other places at the same latitude. Then, after giving up its heat, the now cooler, denser water sinks and begins a long, deep return toward the equator. It's a cycle that links the warm places and the cold places, connecting shorelines and cities, fishermen and surfers, all by invisible motion. This global conveyor belt isn't fast. It's patient. It can take 1,000 years for a single drop of water to travel the world. One drop might set off from the Caribbean, move north with surface currents, sink near Greenland, and then drift slowly along ocean depths, only to surface near Antarctica centuries later. That tiny journey is a reminder that the planet's rhythms operate on timescales far longer than our daily routines. There's something strangely comforting about that, like knowing a great machine is always humming, steady and reliable, beneath our hurried lives. Think about what this means in everyday terms. The summers you remember, the winters you complain about, the fishermen who time their seasons, the migratory routes of whales and fish. Each is shaped by these currents. When warm water arrives at a coastline, it can fuel storms or calm them. When cold water resurfaces, it brings nutrients that feed plankton, which feed fish, which feed communities. Coastal towns from Senegal to Nova Scotia are connected by this fluid highway in ways most of us never see, but all of us feel. Stand on a pier at dusk and picture the ocean as a great circulatory system. Just as your heart and blood distribute warmth and oxygen through your body, the ocean's currents distribute heat and chemical signals across the planet. That analogy makes it personal. The ocean is, in a sense, Earth's bloodstream, and its circulation supports the global systems we depend on. Weather patterns, food webs, even the warmth in our homes in colder months. When the conveyor belt flows as it should, the world's climates stay within the bounds we expect. When it slows or shifts, those bounds can change. People who live by the sea know the ocean's moods in a way city dwellers don't. A lobster fisherman, a surf instructor, a coastal farmer, they notice small changes, timing of migrations, the size of catches when the fog rolls in. Those observations are the human side of ocean science. Scientists watch the same system with instruments and models, but it's the combination of lived experience and long-term measurement that tells the full story. Currents are not abstract. They are part of our daily lives. And because this conveyor belt is so slow, its changes can be subtle but long-lasting. The system remembers history. A disruption today might take decades or centuries to fully play out. That idea should make us feel humble. Our actions have consequences that echo far beyond our lifetimes, and also motivated to pay attention. We pass the planet along, not like a flickering phone signal, but like a river that will keep flowing for generations. Visually, show maps that trace a single drop's path, then cut to faces. A child throwing a pebble into a tidal pool, an old fisher checking nets, a scientist lowering an instrument over the side of a research vessel. These images close the gap between wonder and reality. The currents of life beneath the surface are massive and slow, but they touch the most intimate parts of our days. The weather we dress for, the food on our plates, the coastlines where we find solace. So next time you're near the ocean, think about the invisible river beneath you. It's carrying warmth and cold, linking distant shores, and quietly shaping the world you know. That single drop taking 1,000 years to circle the globe is also part of your story, part of the long unfolding conversation between Earth's waters and the lives they sustain. Picture this. You're standing on the railing of a small boat, salt in the air, the ocean stretching in every direction. Then the water ripples. A dark shape glides beneath the surface, and suddenly the sea exhales, a towering plume of mist and spray rising up like a chimney against the sky. Your chest tightens, not from fear, but from an odd, quiet awe. In that moment, you're not just looking at an animal. You're standing next to a being that redefines what big even means. Blue whales are the giants of today in the most literal sense. When scientists say they're the largest animals ever known, they mean it, bigger than any dinosaur. That puts them beyond our usual scale of comparison. If you've ever tried to imagine the size of a T-Rex, multiply that image by a dimension that seems almost impossible to picture. A blue whale can reach lengths of around 100 feet, longer than a basketball court, and weigh as much as several loaded freight trucks. For most of us, those numbers are abstract. So think instead of things you know, their hearts weigh as much as a small car. Imagine a car-sized heart beating inside an animal, slowly and deliberately, like a massive metronome keeping time for a life lived under pressure. That slow heartbeat is part of what makes whales so remarkable. When a blue whale dives deep, its heart can beat only a few times per minute. Compare that to your own resting heart rate, which probably hovers somewhere between 60 and 80 beats per minute, and you begin to understand how different their physiology is. Those slow beats are an adaptation, conserving oxygen, managing pressure, and allowing a mammal of immense size to survive long periods underwater. It's intimate, in a way. Knowing that the creature breathing in the open ocean can slow down its very rhythm to match the depths makes them feel less like myth and more like a fellow traveler with a radically different tempo of life. And when they surface, their breath is a spectacle. A blue whale's exhale, the spout, can rise higher than a house. Imagine standing in a neighborhood and watching a plume taller than a 2-story building punch into the sky. Dramatic, almost theatrical. For people who've seen it in person, that sight is often followed by a stunned silence. Even cameras and drones struggle to capture the scale and the hush that follows. It's one thing to watch a documentary, and another to feel the spray on your face and to hear, for a second, the ocean's rhythm reset by that single massive inhalation. Then there's the sound. Whale songs are one of those natural phenomena that manage to be both scientific fact and poetic truth. Blue whales and their relatives produce calls that travel for hundreds, even thousands of miles through the ocean. When a whale sings, the sound is carried by a medium we can't see, water, but somehow we recognize the impact. Think about how a song can make you feel seen in a crowded room, or how a voicemail can take you back to a memory. Now scale that intimacy up to the size of an ocean. Researchers have recorded notes so low and so long that they bounce across basins, refract through layers of different temperatures, and arrive at distant receivers altered, but still recognizable. Voices of the Deep That Never Fade isn't just a poetic flourish, it's an observation about persistence. Those songs move, reflect, and connect individuals separated by continents. That connectivity matters in a way we can relate to. We often talk about the internet or smartphones when we describe how connected we are. But imagine a communication system that's been in place for millions of years. No wires, batteries, or satellites. Just the physics of sound and the bodies of animals adapted to use it. Whale calls can coordinate migrations, find mates, and maintain social bonds across vast distances. For communities of humans who depend on the sea, these calls have been part of the background score of life for generations. For scientists, they're a window into behavior we otherwise could only guess at. On a personal level, encountering a whale changes how many of us perceive scale and responsibility. After you've seen a spout lift into the air or heard a low-frequency call on a hydrophone, it's hard not to feel a protective instinct. The idea that such gentle, enormous creatures roam the oceans, creatures whose songs echo for miles, brings a sense of humility. It invites a question. What role do we want to play in a world with whales in it? These animals survived mass extinctions, adapted to cold and pressure, and evolved communication that reaches across oceans. Their survival intersects with our choices more than we often admit. Shipping lanes, fishing gear, climate change, and noise pollution all shape the soundscape and the habitat these giants rely on. So when you next see a photograph of a blue whale, or when a movie shows a huge creature gliding beneath ice, try to let the facts resize themselves into something you can feel. Imagine a heart the size of a car, beating a few patient times each minute. Picture a spout slicing the air taller than a house. Listen, even in your head, to a song that rolls and repeats and can be heard by a whale in another ocean. Those images turn statistics into a relationship. They make whales less like distant curiosities and more like neighbors, enormous, mysterious neighbors whose daily lives are interwoven with the health of our planet and the choices we make. Cut to underwater footage of a blue whale singing. Low-frequency sound fades in under narration. Keep that image with you as we move on, because understanding these giants isn't just about marveling at size. It's about recognizing the connections and responsibilities that come with sharing a planet with beings that, in many ways, redefine what life can be. You start to realize just how personal dolphin communication can when you imagine someone calling your name across a crowded beach, the way everything tightens in your chest and you turn, looking for the source. Now picture that moment underwater, with sound shaped into whistles and clicks instead of syllables. That's what scientists mean when they say dolphins have names. Dolphins don't just squeak and chatter. They whistle in patterns so distinct each one acts like an acoustic signature. Think of it as a voice print, a unique curve of pitch and timing that, when heard, says that one without another word. Biologists call these patterns signature whistles. They're not random. From the moment a calf starts shaping its own sound, it develops a whistle that serves as its identifier. Play that whistle back to the group, and the right dolphin often responds, sometimes immediately, sometimes with an excited burst of movement. It's the underwater equivalent of hearing your name and turning around. I remember being at a crowded party once. You know that little jolt when someone says your name across the room? That feeling of being singled out, recognized? Dolphins get that too, except their names travel hundreds of meters through water, carried by waves and currents, and are shaped by frequency and timing rather than consonants and vowels. Researchers have played back recorded whistles to dolphins to test recognition. When a dolphin hears a recording of its own signature whistle, the reaction is often stronger, than to any other sound. A reorientation, a curious look, sometimes a whistle in return. That reaction is a clean, behavioral signal. The dolphin recognizes the name and answers. What's even more fascinating is that dolphins don't just stick to their own names. They learn to imitate the signature whistles of others and use them as calls. Two dolphins who are friends, siblings, or a mother and calf will sometimes exchange each other's signature whistles across the water. It's a deliberate, directed form of address, essentially calling another individual by their name to get their attention, to reassure, to coordinate. Think about how you might use someone's nickname to get them to relax, or how hearing a friend mimic your voice can make you laugh. For dolphins, imitation can cement relationships. When one dolphin answers another with a copied whistle, it's often an intimate move, a way of saying, "I'm thinking of you," or "come closer," in an unmistakable, individual way. Signature whistles aren't handed down like surnames. Calves develop their own whistles early in life, shaping sound through social feedback. Some research suggests they may incorporate elements from the whistles they hear most. Think of a child borrowing a friend's catchphrase, but they still produce a distinct pattern that marks their identity. That process shows creativity and social learning, not just instinct. All of this, unique signatures, recognition, imitation, points to a complex system of individual reference. It's not just emotion or alarm calls. It's a way to identify and address specific individuals. That kind of referential signaling is something we often associate with human language, and seeing it in dolphins stretches our definition of what language can look like. Knowing that dolphins have names changes how you see them. They're not just a group of animals in the water. They're a community with members who are recognized, called, and remembered. When a dolphin answers its signature whistle, you can almost picture a tiny social world unfolding. Friendships being acknowledged, separations resolved, bonds renewed. And there's something quietly humbling about it. Language, identity, and social lives don't belong exclusively to our species. Intelligence finds its channels wherever life needs to be understood, through air, through gesture, or, in this case, through the shimmering, pulsing medium of the sea. These signature whistles are just one window into dolphin minds. Once you accept that they call each other by name, everything else, their problem-solving, empathy, and culture, starts to make more sense. Up next, we'll look at how those social calls power group decisions and even shape dolphin traditions. A name is a promise of recognition. Out here, between the waves, that promise is audible, carried on whistles, answered with movement, and kept alive by memory. Think about the oldest person you know, a grandparent, a neighbor, someone whose stories stitch together different eras. Now imagine a creature that has been moving through the world for longer than any human life, longer than civilizations, longer even than the forests that shade our planet today. Sharks swam Earth's oceans long before trees reached up from the soil. That breathing, gliding presence in the deep is not just ancient in a poetic way. Some of these animals are literal time capsules. Take the Greenland shark, for example. Scientists estimate some individuals can live for over 400 years. Pause and let that sink in. 4 centuries drifting through icy waters, century after century, experiencing geology on the scale of glacial advances and retreats, outlasting ice ages, surviving the same cycles that wiped out countless other forms of life. When I first learned this, I remember feeling both humbled and wildly curious. What does it mean to live so slowly, so steadily, when everything around you changes? These sharks are built for endurance. They move through dark, frigid depths where metabolism slows and danger is parsed differently than it is near the surface. You can almost picture them as elders of the sea, carrying histories none of us can read but all of us benefit from. They've been shaped by time into efficient, durable designs. Blunt snouts, sluggish but purposeful movement, a body optimized for conserving energy. Evolution didn't need to reinvent the blueprint. It refined what worked until change was almost unnecessary. That's part of what makes ancient sharks so relatable. We like to think of evolution as constant transformation, but sometimes the best adaptation is stability. Imagine finding a tool in your attic that still works perfectly after 100 years. You'd marvel at its craftsmanship, the way its maker anticipated a need that persisted. Sharks are like that tool. Their form and function have been refined so well that millions of years passed with only subtle tweaks. And there's something personal in that endurance. When you hear about a creature that survived mass extinctions and ice ages, it reframes time. It makes your own lifespan look different. A single note in a symphony that has been playing for eons. Yet these sharks are not distant relics. They're living now. Knowing that someone, something, has been present through chapters of Earth's story we will never witness gives a strange comfort. It's a reminder that life can persist through upheaval, adapting not just through rapid change, but through remarkable constancy. But constancy doesn't mean invulnerability. Human actions have sped up transitions in ways ancient species were never primed to handle. Greenland sharks and their kin face newer threats: warming seas, shifting ecosystems, plastics and pollutants filtering into the deep, fishing practices that weren't part of the script written over millennia. Their ancient resilience is remarkable, but it's not a guarantee against abrupt modern pressures. That contrast, age-old endurance meeting sudden human-induced change, is something personal we can relate to. It's like watching an old family business struggle when the neighborhood suddenly transforms. Respect for its history doesn't protect it from new realities. I like to imagine encountering one up close, the slow, deliberate presence, the dark cloak of its skin, the unhurried blink of an eye as it passes through a world that has changed in ways the shark never needed to anticipate. That image sticks with you because it's a bridge across time. These animals remind us that some designs are so sound, they become timeless, and that endurance can be a form of wisdom. They invite us to consider our own relationship with time, change, and care. For if creatures that survived ice ages now need our help, perhaps longevity is a shared responsibility. So next time you read about an ancient species, try to picture not just the facts, but the feel of it, the slow turning of centuries in a single body, the quiet resilience, the way survival can be a steady, patient art. There's something deeply human in admiring that, in wanting the things we value to outlast us, and in understanding that sometimes protecting what's old and wise also protects our future. Picture yourself drifting in a small submersible, the world outside a windowless black. Your headlamp picks out a faint, ghostly outline, not a rock or a plant, but a body so thin and clear, it's almost as if nothing is there. That's the deep for you. Creatures that have chosen to disappear because being seen equals being eaten. In the black depths, invisibility isn't fantasy, it's a daily strategy. These are the ghosts of the deep. Start with transparency. Some animals, many jellies, glass squids, and siphonophores, have bodies built like living glass. Their tissues are tuned so light passes through rather than bounces back to give them away. If you've ever watched aquarium footage of a glass squid, it feels like watching negative space move. I remember the first time I saw one on video. My brain kept insisting there had to be something to look at. Yet the animal was literally a silhouette of absence. That absence is function. By reducing pigments and matching the refractive index of their tissues to seawater, these animals erase their outlines. When a hungry predator scans for contrast or motion, there's nothing to lock onto. But transparency has limits. Eyes, guts, and muscles can't be made perfectly invisible. That's where another trick comes in: counter-illumination. Many midwater animals carry tiny light-producing organs, photophores, on their bellies and can match the faint, downwelling light from above. From below, they vanish against the dim glow coming from the surface. Imagine wearing a light on your chest that exactly matches the shade of the sky. Suddenly, you stop casting a silhouette. It's a living invisibility cloak, tuned by evolution. Then there's the opposite approach. Be as black as the void. Some deep-sea fish aren't merely dark. Their skin is engineered to swallow light. The black dragonfish and several species of anglerfish and slickheads possess ultra-black skin that absorbs nearly all the light that hits it. Research shows they pack their skin with tiny melanin granules arranged to scatter and trap photons, preventing even faint bioluminescent glows from reflecting back to an observer. Watching footage of one of these fish is eerie. They are the kind of black that kills depth perception, like a hole in the ocean. I always imagine them as stage magicians. While one part of the sea attracts attention with a lure or flash, their body is the perfect shadow from which a strike can begin. You can see how these strategies shape behavior. Predators that hunt with bioluminescent lures, anglerfish being the classic example, pair a glowing lure with an ultra-dark body so the prey fixates on the light and doesn't register the silhouette of the attacker. Prey species, meanwhile, evolve transparency or counter-illumination to slip by undetected. It's a continuous arms race where invisibility is currency. There's something human about this invisible struggle. Think about trying to blend into a crowd or wearing clothes that match your surroundings to avoid being noticed. That instinct to hide, to go unnoticed, is familiar. Deep-sea animals have taken that instinct to the extreme, sculpting skin and light over millions of years until they become phantoms in a world without day. But invisibility here isn't only about defense. It's also poetic. These ghosts are reminders that absence can be as significant as presence. When a clear-bodied siphonophore drifts by, it's not empty space. It's a finely tuned machine, each translucent part doing its job in the ballet of survival. And when an ultra-black fish vanishes against the night, it's not an absence of life, but a sign of evolutionary cunning. As the submersible motor hums, you begin to appreciate how alien and oddly intimate this world is. The deep sea forces life to invent ways of not being seen, and in doing so, reveals just how creative and relentless evolution can be. Up next, we'll meet some of these ghosts up close, the glass-bodied hunters and the pitch-dark ambush artists, and see how their invisible tricks are filmed, studied, and sometimes even mimicked in human technology. But here's something that always blows my mind. The sea actually holds more gold than all the mines on land combined. Scientists estimate roughly 20 million tons of gold are dissolved in the oceans. Say that out loud the next time someone tells you the ocean is empty. 20 million tons. It sounds like a pirate's dream, right? A glittering fortune waiting to be scooped up. When I first heard that, I pictured myself as a modern-day explorer, dredging the seabed with some sci-fi contraption and coming home rich. Then I learned the rest of the story, and it felt like someone had shifted the goalposts. That gold is there in a literal sense, but it's spread out so thinly across the vastness of the ocean that it's effectively unreachable. Imagine a single teaspoon of seawater. In that teaspoon, there might be a few billionths of a gram of gold, trace amounts. Multiply that by all the water in the planet, and you get millions of tons. The math is almost poetic. Enormous total, infinitesimal concentration. Why can't we just collect it? Two simple reasons: physics and practicality. The gold is dissolved at such low concentrations that any process to extract it would need to filter or process unimaginable volumes of water. The energy, infrastructure, and time required would far outweigh the value of the gold you'd recover. On top of that, any large-scale attempt to mine seawater would almost certainly wreck marine ecosystems. The ocean's processes are delicate. Currents, nutrient cycles, microscopic life forms. You can't run heavy machinery through that without consequences. So although the ocean's ledger shows a staggering amount of gold on paper, we don't and practically can't turn that quantity into coins or jewelry. And that's what shifts my perspective. The ocean's treasure isn't a hoard of gleaming metal waiting for our take. Its riches are quieter, woven into the living fabric of the sea. For most of my life, the shoreline has been a kind of therapy. The wind, the rhythm of waves, the way moonlight shivers on water. I used to stoop and pick up odd shells and stones, thinking the pretty ones were the treasures. Now I see those moments as a tiny part of something much bigger, a reminder that what the ocean gives us isn't measured in carats. Take oxygen, for example. Half the oxygen in the air we breathe comes from the ocean, from phytoplankton, the microscopic plants floating near the surface. They photosynthesize, turning sunlight and carbon dioxide into oxygen and building blocks for marine food webs. Every breath you take, part of it was gifted by a tiny organism that lives in water. That fact makes the sea feel less like a distant commodity and more like a living, breathing partner in our survival. Then there's the abundance of life, vast schools of fish, the slow ballet of whales, the sheer variety of corals and sponges, the noisy, busy world of shorebirds. Lifestyle and livelihoods of millions of people depend on these ecosystems: fishermen, coastal communities, the chefs who rely on fresh catches, the families who simply value a day at the beach. The ocean stores food, regulates climate, absorbs carbon, and buffers storms. Those are practical riches that directly affect our lives in ways a pile of gold never could. There's also the element of mystery. I think that's why so much of the ocean's allure endures. We've mapped the moon better than we've mapped the deep sea. Phenomena like bioluminescence, migration patterns that span entire hemispheres, and microbial communities that thrive near vents where metal-rich fluids meet icy water. They're reminders that we are still learning how life adapts and thrives under pressure. in darkness, in conditions we once thought impossible. That unknown is a kind of treasure too, the potential for discoveries that can change science, medicine, and how we see our place on Earth. If you stand on a rocky headland and watch the light break across the waves, you can feel this trade-off between glitter and substance. The gold is there, but the real wealth is the living, breathing complexity that produces our oxygen, feeds our families, and keeps the planet habitable. It's not as showy as a chest of doubloons, but it's everything. So when someone mentions the ocean's hidden gold now, I picture not piles of metal but invisible threads of value. The plankton making the air, the reefs sheltering life, the currents balancing climate. Those are the treasures that sustain us. And because they're fragile, they need our attention more than any hypothetical gold rush ever would. Next, we'll look at where some of the ocean's more tangible mineral deposits do accumulate, places like hydrothermal vents and manganese nodules, and why even those fields of resources present both opportunities and big ethical questions. Beneath the waves lie millions of shipwrecks and even entire cities, time capsules of human history preserved in the cold dark. Picture lowering yourself into that silence. The world above muffled, light narrowing to a blue ribbon, and then a hulking shadow appears. A mast, a carved figurehead, a row of sunken columns. For me, that image is the closest thing we have to stepping into someone else's paused life. Take Egypt. Off the coast of Abukir Bay, archaeologists found the lost city of Thonis Heraklion and nearby Canopus, temples and houses buried in silt and sea. Statues still sat where priests once walked, and offerings lay undisturbed for millennia. It's humbling to realize the people who prayed at those altars had the exact same human rhythms we do, waking, tending family, bargaining in the market. And then their city slipped beneath the waves. Diving through those ruins is like reading a letter from a past civilization. It's intimate, a reminder that history isn't only dates and names, but everyday lives. Further north, the Baltic Sea keeps shipwrecks almost perfectly intact. The cold, low salinity waters are hostile to the wood-eating organisms that destroy wrecks elsewhere, so galleons and warships lie on the seabed like time-stopped museums. Imagine the slow discovery of a 17th century warship, its cannons still in place, its rigging collapsed like a sleeping animal. For divers and historians, those wrecks are incredibly powerful. They tell us about trade routes, naval tactics, the materials people trusted and threw away, even the kinds of food they ate on long voyages. That sense of personal connection is everywhere under the sea. A lone copper coin clutched in sediment can reveal where a sailor once hoped to buy bread. A child's toy near a household hearth makes a shipwreck story heartbreakingly human. We instinctively imagine the faces behind these objects, the frustration of a captain, the excitement of merchants, the quiet rituals of families. And that imagination turns cold artifacts into people we can almost meet. The ocean does not only erase, it keeps our stories safe in silence. In deep, oxygen-poor water, decay slows. Layers of silt can act like a blanket, preserving wood, textiles, even papyrus. But preservation is also fragile. When we bring treasures to light, they begin to change instantly. Conservators work like doctors, bathing artifacts in carefully controlled environments So those letters, statues, and ship timbers can be read and touched again without falling apart. There's also a moral echo here. These wrecks are graves, archives, and cultural heritage all at once. Some belong to nations that no longer exist, some to families still looking for closure. Every recovered object raises a question. Do we retrieve it for museums and study, or do we leave it sleeping, respecting the silence that has protected it? That tension makes the work of underwater archaeology not just technical, but deeply human. So when you think of the ocean tonight, don't just picture fish and waves. Think about the places where entire worlds have been paused, waiting quietly under the water's skin. Rooms frozen in time, warships holding their secrets, temples where sunlight once streamed indoors. Those silent stores of memory remind us that history can sink, but it rarely disappears. Beneath the shimmering surface, whole cities rise. But they weren't planned by architects. They were built grain by tiny animals you can barely see with the naked eye. When I first dove into one of these coral gardens, I felt like I'd slipped into an alien metropolis. Streets and towers made of living stone, neighborhoods of branching growth, where every nook sheltered a secret. Coral reefs are the ocean's rainforests. Dense, noisy, impossibly colorful. Each coral head is made from thousands of soft-bodied polyps that secrete calcium to build skeletons. Over centuries, those skeletons stack up into branches, plates, and boulders. From a distance, they look like hard rock, but look closer and you discover soft curtains, waving tendrils, and tiny mouths opening and closing. They're not just structures, they're homes, farms, and nurseries for a staggering variety of life. At night, if you catch the reef under ultraviolet light, it transforms. Some corals fluoresce, like organisms hoarded bioluminescent glitter, blues, greens, hot pinks, turning reef slopes into fields of living stars. The sight is almost unreal, a slow-motion galaxy where fish move like comets through constellations of glowing coral. I remember my first night dive thinking the ocean had traded its dark suit for a sequined gown. It felt intimate and sacred. Life there is intensely social. Fish of every color and pattern weave through the coral's branches, slipping between crevices like people moving through alleyways. Damselfish dart and defend tiny plots of algae. Parrotfish crop and polish the reef surface. Schools of tiny anthias hover above a coral table, synchronized like a flock suspending itself in mid-water. Each species occupies its own micro-neighborhood, shaped by the coral's architecture. Sound plays a surprisingly large role in this neighborhood. On warm twilight dives, you can hear the reefs crackle, a chorus of snapping shrimp, creaking coral, the rasp of grazing fish. It's not just background ambiance, it's a map. Young fish raised in pelagic nurseries use that sound to find home. Scientists have shown that fish hatchlings and juveniles listen for the reef's particular acoustic signature and swim toward it, guided by the creaks and pops. Imagine being a tiny traveler and following the sound of your future neighborhood like a radio beacon. That idea, that place can be found by listening as much as by seeing, makes reefs feel even more personal. When you're floating above one, eyes wide at the color and form, there's also a sense of standing at the edge of a conversation you weren't meant to overhear. You feel the reef's pulse in your chest, the same pulse that calls the young home. that holds species together and that hums beneath the drama of predator and prey. If you've never swum inside a coral garden, picture this: sunlight slanting through water, shafts of gold catching dust motes, a coral head glowing faintly as night approaches, a small fish slipping past your hand and vanishing into a coral maze. It's intimate, fragile, and animated with the accumulated lives of countless tiny builders, a luminous, crackling city that needs plenty of care to keep shining. Think about intelligence we expect: books, cities, speech. Now picture a brain that grew where none of those things exist, a mind shaped by currents, crevices, and the long, quiet dark. Octopuses make you rethink what thinking can look like. There's a clip that always stops me: an octopus in a research tank unscrewing a jar to get at a crab inside. It nudges, pulls, finally hooks a sucker under the lid, and pries it open like someone slowly turning the stubborn cap on a pickle jar. The patience, the sequence of moves. It's not random, it's strategy. And that's the common thread. They solve puzzles, remember solutions, and sometimes even teach one another. If you've seen footage of an octopus slipping out of a seemingly sealed aquarium and gliding across the floor to the next tank, you know they are escape artists with a knowing calm. They compress their soft bodies through impossibly small gaps, then, once safely on the other side, often leave the lid exactly where it was. It's cheeky, almost playful. It makes you smile, and then quietly, a little unease settles in. Who else thinks like this? Tool use makes their cleverness even more human-feeling. Some octopuses gather coconut shells and stack them, carrying the halves like portable armor. When threatened, they assemble the shells into a protective shelter, an octopus wearing a suit of coconut cups. Others have been filmed dismantling shells, using them as shields, or even arranging rocks to block den entrances. For a creature without a skeleton, fashioning and using objects is a profound expression of forethought. And mimicry, my favorite, shows imagination. The mimic octopus can contort and color shift to imitate lionfish, flatfish, or sea snakes, adopting not just color, but posture and motion. It's deception as survival, but it also looks like performance art underwater. You can't help but admire the show and the intent behind it. Biology adds an almost sci-fi layer. They have 3 hearts, pumping blood that's blue because it's copper-based. Their skin is a living canvas, millions of specialized cells letting them change color and texture in a blink. One moment muted gray, the next an electric flash of warning. That instant transformation makes their emotions and decisions visible in ways mammals can only hint at. In the deep, all this feels almost alien. Watching an octopus move through cold, silent water, you sense a mind born from water, curiosity, and silence. A consciousness that navigates by touch and taste as much as sight. It's not an animal thinking like us. It's an intelligence that evolved along a wholly different path, and it invites us to expand what we mean by smart. So when you see an octopus solve a puzzle, slip through a gap, or assemble its little coconut shield, don't just admire the trick. Let it make you wonder about the experience of another kind of mind, one that's clever, curious, and quietly other species. That curiosity is contagious. It's the bridge that lets us care. Picture yourself standing at the water's edge at dusk. The sky has gone violet, the surf murmurs, and the horizon looks like a promise you can't quite read. That feeling, a mixture of comfort and not knowing, is exactly what the ocean gives us, even now, after centuries of mapping, fishing, and sailing. It's strange to admit, but despite all our technology, more than 95% of that vast, breathing world remains unexplored. Think about that for a second. We've flown probes past Jupiter, landed rovers on Mars, and imaged worlds light years away. We can measure the heat of an exoplanet and hear the faint echo of a black hole. Yet beneath the waves, beyond the reach of sunlight, entire mountain ranges rise and fall in invisible silence. Whole ecosystems exist in pressures so crushing a human could never survive them without machines. There are species that don't just hide from us. They simply have never had an encounter with anything human-made. That's not hyperbole. For all our satellites and submarines, our maps of the seafloor are patchwork at best. We know more about the topography of Mars than we do about some coastal trenches a few miles off our own shores. It's humbling. The satellites that pass overhead can tell us about the ocean's surface, temperature, color, the plant life at the top, but they can't see the deep valleys and towers that rise from the seabed. Submersibles get us closer, but they're slow, expensive, and limited by pressure, battery life, and the sheer scale of the oceans. So what we have is a mixture of high-resolution snapshots and vast blank spaces where our curiosity has yet to land. Maybe the most exciting part is imagining what's in those blank spaces. In the last few decades, we've discovered hydrothermal vents that support entire ecosystems without sunlight, fed instead by chemical energy. We've watched creatures glow with bioluminescence as if the ocean itself were studded with tiny living stars. But for every vent and glowing squid we've filmed, there could be dozens of life forms that don't fit any model we've built. Organisms whose chemistry, movement, or social behavior would force scientists to rethink how life can exist. I like to picture those unknown species not as monsters in horror films, but as actors in a story we haven't written yet. Maybe they're slow, shapeless beings that filter nutrients from underwater clouds. Maybe they communicate in flashes of light or in pressure pulses we haven't learned to read. The ocean has a way of producing solutions that feel alien because the conditions are so different from life on land. And that's exactly why the mystery is so rich. Discovery down there could teach us about resilience, adaptation, and the limits of biology itself. There's also a human story to this mystery. When we say unexplored, we're not just pointing at unknown geography, we're pointing at missed opportunities. Medicines made from marine organisms are already part of modern medicine, and who knows what cures or technologies are waiting on the ocean floor. There are cultural histories tied to these places too, shipwrecks that hold stories, lost coastlines swallowed by rising seas, and communities whose livelihoods and myths are entwined with those depths. But exploring the deep ocean isn't just a technical challenge. It asks something of us emotionally. It requires patience in an era that prizes speed. It requires funding, international cooperation, and a willingness to value knowledge that doesn't promise an immediate profit. It also requires humility, accepting that despite our best instruments, nature can still surprise us. So the next time you stand by the water, try to feel that mystery. Let the fact that most of the ocean remains unknown be a comfort rather than a deficit. It means there is still room in this world for wonder, for exploration, and for discoveries that change how we see life itself. Somewhere in that dark, cold, alien vastness, life might be doing things we haven't even imagined, and that possibility should be one of the most inspiring facts we carry forward. Think about the last time you stood at the edge of the sea, the wind tugging your hair, that sharp salt on your lips, the steady, indifferent roll of the waves. It's easy to forget, in that moment, that you're touching something unimaginably old. Those same waters that cool your skin and blur the horizon once held the very first flickers of life. Billions of years ago, long before forests or mountains as we know them, the ocean was a warm, mineral-rich soup. Floating in that salt water were tiny parcels of chemistry, simple membranes trapping molecules, proteins folding, nucleic acids forming loose patterns. Those were the ancestors of every cell inside you now. Scientists look at stromatolites and ancient rock layers and push those dates back to 3.5, maybe even 4 billion years. That's not just a fact. It's a family portrait that stretches all the way to the beginning. When you imagine the first cells, don't picture anything dramatic. They were microscopic and patient, drifting with currents, powered by sunlight or the chemical energy leaking from the seafloor. They carried the basic tricks life still uses: membranes to hold a tiny chemical world together, a way to copy information, and a metabolism to harvest energy. Those simple solutions multiplied, mixed, and occasionally fused into new ones. Over eons, that chemistry became complexity, chains of living systems reaching toward forests, wings, brains, and cities. The ocean was the lab where the experiment of life got started, and the ocean hasn't stopped doing its job. It still shapes the weather that determines whether crops succeed or fail, steering storms and distributing heat around the planet. You feel that work when a coastal breeze rolls inland on a hot day, or when a hurricane that formed over warm waters bends toward your hometown. It's the ocean's heat capacity and currents that keep the planet from flipping between extremes. A vast, patient regulator. Breath itself is a reminder of this connection. Half the oxygen we inhale is made by microscopic marine plants and bacteria, phytoplankton, photosynthesizing near the ocean surface. Tiny, shimmering life forms, invisible from a boat, quietly supply a lungful of air for every second person on Earth. When you take a breath, you're tasting work that began in the salt water. Even the iron and minerals they need pass through the ocean's cycles, drawn up in currents, sinking and resurfacing in a rhythm older than any human calendar. The sea is also a memory bank. Sediments on the seafloor store chemical fingerprints of ancient climates. Fossils and microfossils preserve snapshots of life's early experiments. When scientists pull up cores from the deep, they're reading chapters of Earth's biography. Eras of warmth, of ice, of sudden change. Our genomes keep a different kind of archive. Traces of bacterial ancestry, of genes stolen and shared across eons. A living record of the ocean's earliest blueprints. That sense of continuity makes the ocean feel like family. Think of the small, almost absurd fact that we are mostly water ourselves. We began in oceans, and we carry that origin inside our bodies. The salt on your skin, the calcium in your bones, elements cycled by tides and currents. They are not just resources, they're reminders. Every recipe handed down in a coastal kitchen, every lullaby hummed while watching waves, every storm story told around a fire ties us back to that first chemistry. And there's hope in that thought. The ocean that gave birth to life still holds remedies and ideas we haven't read yet. Medicines hidden in coral chemistry, new sources of food, renewable energy riding tides and currents, and models for resilience in the face of change. Because the sea has been patient and enduring, it invites us to think long-term the way evolution does. Incremental, persistent, and generous. So when you next stand at that waterline, take a breath and remember what's beneath and behind it. The ocean is not only the cradle that rocked the earliest cells, it is the living system that breathes with us, shapes our weather, and keeps a ledger of our shared past. It is both our past and our future, patient, eternal, and quietly indispensable. And so our journey ends where it began, on the calm surface of the ocean. We've explored glowing depths, ancient reefs, and the quiet intelligence beneath the waves. Breathe with the tide. The ocean asks only wonder and returns deep, endless peace. Sleep well. Dream gently as the sea cradles your thoughts till morning.